Welcome to solverfy.
Hello, we have a rod and the mass of the rod from the left end to the point which is at a distance of x meters from the left end is 5x square. Let us denote by mx the mass of the rod from the left end to the point which is x meters to the right of the left end. Let us denote this function by mx. It is given that mx equal to 5x square, and we have to find the linear density of the rod at various points along the rod. Now the linear density of the rod is defined by um, if we denote the linear density by rho x, it is defined by small change in mass by, well, we can also write it like this. If the linear density at a point, let us denote the linear density at a point, let rho x be defined as the function which gives the linear density, whose value is equal to the linear density at a point x meters to the right of left end. Then if we then this is a point that is x meters from the left end, and suppose that we take a point that is at a x plus dx, that is at x plus dx from the left hand, then this is the portion of the rod that lies between x meters and x plus dx meters from the left hand. Then we have that the mass of this portion of the rod, if we denote by dmx, this is the change in the mass of the rod, so mass of this portion of the rod will be dmx. This thing by the length of this portion of the rod, which is tx, this thing will be equal to the linear density of the rod at this point when dx approaches 0, or in the limit dx goes to 0. And this thing is nothing but, actually we should have used, I guess, delta instead of d, but let us move on. And this thing is nothing but m prime of x. Sometimes the linear density is straightaway defined as m prime of x, and sometimes it is defined in terms of this relationship. Anyway, the linear density at a point x from the right x from the left end is equal to the derivative of m prime x. This is the function. This is the relationship between rho x and mx. But mx is given to be 5x square. This implies that rho x equal to m prime x, which is equal to 10x, and the units will be kg per meter. Since mx has units kg and x has units meters, m prime of x will have units kg per meter. So it will be 10x kg per meter. This will be the linear density at a point x meters to the right of the left hand. Once we have this, we can answer part A, which is the linear density at a point 10 meters, sorry, at a point 2 meters from the left hand. It will be equal to 10 times 2, which is 20 kg per meter. Now in part B, we are asked what is the linear density at a point 4 meters away from the left hand. 4 meters to the right of the left hand. This will be equal to, we plug in 4 into this equation, we'll get 40 kg per meter. Similarly, the linear density at a point 6 meters, 6 meters from the left hand is, we plug in 6 into this, we get 60 kg per meter. And in part C, we are asked, in part D, we are asked at which point of the rod is the linear density maximum. Now we can see that the linear density is increasing as x increases. So the linear density will be maximum when rho x is maximum, when x is maximum. This implies rho x is maximum at um, the right end of the rod, at the right end of the rod. Similarly, since the linear density is increasing to the right, we can conclude that the linear density will be minimum at the left end of the rod. And this completes our solution to this question. I hope this is useful. Thank you.